Good afternoon. I am Shail, Assistant Professor in Department of Electronics and Communication Engineering, AKGEC, Ghaziabad. And today I am going to discuss basics of operational amplifier. Actually, we need to understand that why operational amplifier is called operational amplifier. It is made up of two words. One is operational and another one is amplifier. One word is operation and amplifier. Actually, this device is capable of performing amplification as well as it can perform several arithmetic operations like addition, subtraction, differentiation, integration. This is why this device is called operational amplifier. Amplification simply means to increase signal strength. For example, if this is the input signal, and if you want to increase its amplitude, then we can give it to any amplifier, for example, operational amplifier, then output may be like this. Its amplitude will increase and frequency will remain constant. And this is the symbol of operational amplifier. And you can see here there are two inputs. One is V plus, V minus. V plus is called non-inverting input. And V negative is called inverting input. And Vs is the positive power supply. And V negative is another negative power supply. And from this you can take output. So why there are two inputs? If you will apply input on this positive terminal, that is non-inverting terminal, then input and output both will be in same phase. For example, if I will apply input on this terminal like this, and I am going to apply it on inverting non-inverting terminal, then output will be like this. Only amplitude will increase and phase will remain constant. You can see this signal as well as this signal, both are in same phase. And if I will apply input on another terminal, that is, so if you will apply input on inverting terminal, for example, this is the input. Then output will be amplified, but it will be out of phase. You can see. This is how these two inputs will work. Two power supplies, output, and this is open loop operational amplifier, as there is no connection between output and input. Same is explained here, that if you will apply input on non-inverting terminal, you will get input and output both in same phase. If you will apply input on inverting terminal, input and output both will be in different phase, that is, phase difference will be of 180 degree. Now, this is the equivalent circuit of operational amplifier, that means how we can understand operational amplifier, how does it works, that can be understood by the equivalent circuit of operational amplifier. See, let us discuss how does it work, how does it can be understood. This is inverting input, this is non-inverting input, this is the input impedance, as this is the amplifier, so this device will amplify the inputs on, and more correctly I should say that this device will amplify the difference of inputs. What are the inputs? One input is V2, another input is V1. So differential input VID will be whatever input we are applying on positive terminal, that is non-inverting, will be denoted as V2, and input we are applying on inverting terminal, that means negative terminal, will be V1. So differential input will be the difference of two inputs, that means V2 and V1. What will be the output? Output will be the differentiation, output will be the amplification of these two inputs. So this differential input VID should be multiplied by V output, will be the difference of V2 minus V1, that should be multiplied by amplification factor. Which is also called as gain. And you can see that this is open loop operational amplifier, so we can also call it as open loop gain. Okay, so this is nothing but this is the output voltage. Z out is the output impedance. So this is how we can model operational amplifier. This is the model that provides us the correct idea of operational amplifier. What is the work of operational amplifier? It can be easily understood that this device amplifies the difference of these two. Okay. This is modeling of operational amplifier. That means if we have operational amplifier, if we'll apply input, then how does it will work? Let us see. Let us apply input V1, V2. These are the two power supplies, and we are getting output here. So what will be output? We have seen that output will be equal to A into V2 minus V1, where A is output, A is gain, V2 is non-inverting input, V1 is inverting input. So this is very similar, which we have discussed in equivalent model of operational amplifier. But here we are going to discuss few more things. That is, V output will be greater than equal to minus VCC and less than equal to plus VCC. Where plus VCC is the negative power plus VCC is the positive power supply. and minus VCC is the negative power supply. So try to understand one thing that any operational amplifier, whatever may be the input, whatever may be the gain, this device cannot provide output more than plus VCC and less than minus VCC. Let us consider one example. For example, if plus VCC let us consider plus VCC is equal to plus 15 volt and minus VCC is equal to minus 15 volt. And if input, let us consider that V1 is equal to 2 millivolt and V2 is equal to 3 millivolt and gain A is equal to 1000. We are considering this example. In this case, what will be output? The output will be equal to A into this V2 minus V1 . So output will be equal to 1000 multiplied by 3 minus 2 means 1 millivolt. That means it will be equal to 1. Volt. If you will increase differential input VID, for example, VID in this case is 1 millivolt. It will be multiplied by gain. Output will be equal to 1. If differential input is 5 millivolt, output will be 1 volt. Condition is gain is equal to this 1000. If input will be 10 millivolt, output will be 10 volt. If input will be 13 millivolt, output will be 13 volt. If input will be 15 millivolt, output will be 15 volt. If input will be 15.5 millivolt, output will be this 15 plus 15 volt. Even if input will be 17 millivolt, output will remain plus 15 volt. Means in any condition, this device cannot provide output more than plus 15 volt. Similar is the case for the negative VID. If VID is equal to minus 15 millivolt, output will be minus 15 volt. If input will be minus 17 volt, output will remain minus 15 volt. Means this is the condition which we need to remember. This is the relation that we need to find out the output, and this is the condition that we need to remember, that in any condition, operational amplifier cannot provide output more than the power supplies. So let us talk about the parameters or characteristics of ideal operational amplifier. There are various characteristics of ideal operational amplifier like input impedance, output impedance, and then differential voltage, slew rate, common mode rejection ratio, shift in characteristics with respect to temperature. So for practical devices, that means like there are several integrated circuits which are available for the purpose of operational amplifier. However, IC 741 is one of the most famous IC for operational amplifier purpose, that we'll talk later, but this time we will talk about the characteristics for ideal operational amplifier. First thing is the open loop voltage gain. Open loop voltage gain means earlier we have seen the circuit of operational amplifier. If the operational amplifier is like this, this will come under open loop. That means if there is no connection between output and input. In this case, ideally gain will be infinity. We will see that gain is infinite in case of ideal operational amplifier. Second parameter is input resistance. Input resistance will also be infinite. For practical amplifier, these parameters means open loop voltage gain, input resistance, these parameters will be very high, they will have high value, but ideally these are infinite. Output resistance should be equal to 0 ideally. Perfect balance. Third thing is perfect balance. In other words, we can call this parameter as offset voltage. If I will consider this operational amplifier V1 and V2, that means voltage of inverting terminal and voltage of non-inverting terminal. Ideally, if I am not applying any voltage, then V1 should be equal to V2. V1 should be equal to V2. That means V2 minus V1 should be equal to 0. This condition is called perfect balance condition. And this condition means input offset voltage is equal to 0. But unfortunately, it will never happen. Practically, it will never be 0. However, it will have very small value. This voltage difference will be around 2 to 6 millivolt. Okay, so this condition is related from previous condition. If V2 minus V1 will be equal to 0, which is nothing but VID, and you know that output is equal to A into VID. If VID will be equal to 0, then V0 will also be equal to 0. So this is what? 0 output voltage when input is 0. But remember, you may think that how it can possible, if input will be 0, then output will also be equal to 0. Ideally, it is correct. But practically, it will never happen in case of operational amplifier. In case of operational amplifier, you will get some small value in output even though we are not applying any input. But remember that we will apply supply voltages. In that condition, we will get some output. Practically, we will get some output. But ideally, we will consider that there will be 0 output if input is 0, if VID is equal to 0 volt. This is another characteristics. Next is infinity bandwidth. That means this device can work from 0 to infinite hertz. However, Actually, we should simultaneously we should remember that practical characteristics and ideal characteristics are different. So you can never think like that bandwidth will be infinite. No, it will never be. But ideally, we will consider that operational amplifier provides infinite bandwidth. Practically, there is no device. You may consider any amplifier, BJT, FET, JFET, MOSFET, operational amplifier. None of them can have infinite bandwidth. But whenever we will talk, ideally we will say yes, it will have infinite bandwidth. That means this, if any device have infinite bandwidth, the significance is very simple. That means this device can amplify every signal irrespective of bandwidth. It will amplify the signal equally, even though signal have 1 kilohertz bandwidth, 1 megahertz bandwidth or 1 gigahertz bandwidth. This simply means that signal may have frequency of 0 kilohertz, 1 megahertz or 1 gigahertz. It will be amplified equally. Okay. Unfortunately, it will never happen. But ideally, we can say that yes, it will amplify all signals irrespective of their frequency. Next is common mode rejection ratio. It will also be infinite. Actually, common mode rejection ratio of the operational amplifier is the measure of capability of operational amplifier to reject a signal that is common to both inputs. Ideally, it is infinite. The meaning is somewhat simple. If we'll understood it like common mode rejection ratio tells us about the capability of operational amplifier, how good it rejects the signal if we are applying same signal to both the inputs. For example, if this is amplifier, if we are applying same input to both the inputs, that time output should be equal to 0. However, ideally it will be 0 because we have seen perfect balance earlier. Ideally, there will be perfect balance. If both inputs are same, then output will be equal to 0. Ideally, it will happen. Due to this, ideally, CMRR will be equal to infinite because there is another relation of CMRR. CMRR is equal to AD upon AC, where AD is differential gain and AC is common mode gain. We have seen that in this case, common mode gain will be 0. Ideally, common mode gain will be 0. So, this device will provide infinite common mode rejection ratio. Now, next is slew rate. Ideally, slew rate will be infinite. So, slew rate is the maximum rate of change of output per unit time and is expressed in volt per microsecond. Okay, so slew rate should also be infinite because change in output with respect to time should be infinite. So, signal of any amplitude, any frequency can be applied to the operational amplifier, and operational amplifier will amplify that signal without any kind of distortion. Zero drift of characteristics with temperature. Practically, there should be no change in characteristics of operational amplifier with respect to time or with respect to temperature. However, again, practically it will never happen. But ideally, we can say that yes, there should be a zero drift or zero change in characteristics of operational amplifier's characteristics. This is the voltage transfer curve. That means if we will apply input, then how does the output will vary? Let us see. If we will see here, this is VD. VD is difference of the two inputs. If I will consider this is minus plus, let us consider this is V1, this is V2. VD will be equal to V2 minus V1. And you know that output V0 will be equal to A into V2 minus V1, where A is open loop gain of operational amplifier, this is open loop operational amplifier gain. V2 is the input applied on non-inverting terminal. V1 is the input applied on the inverting terminal, and V2 is the input applied on the non-inverting terminal. So initially, when this difference will be V2 minus V1 will be small, and if it will be multiplied with gain, output will increase linearly with respect to input, like this. In this direction also, when this difference will be negative, it will change like this. But at most, maximum output can be plus V saturation. You can see this. That is nearly equal to positive power supply. And maximum negative voltage will be equal to minus V saturation, which is equal to negative power supply. So in any condition, this device cannot provide output more than plus V saturation and minus V saturation. And remember that in this region only, let me change the color. In this region only, operational amplifier is working as a linear device. This is linear region. After that, it will saturate. Once the device will enter into the saturation region, if you will keep on increasing input, output will not change. Output will remain fixed on plus V saturation and minus V saturation. So whenever we use operational amplifier for the amplification purpose, we use operational amplifier in linear region only. Okay, so these are the characteristics of operational amplifier, or more specifically I should call that this is the voltage transfer curve. And today we have discussed the basics of operational amplifier. In next lecture we will discuss some applications of operational amplifier. Thank you.